Welcome back, science enthusiasts. We are back with another interesting topic. Today, we are delving into the fascinating reality of friction. Friction is a force that resists relative motion. In short, it helps stopping something. Wait, it doesn't only help stopping any type of motion. It helps initiating it too. Consider a universe without friction. What implications would it have on us? The most obvious change we would feel is inability to walk or move. You must be thinking, why wouldn't we be able to walk without friction? Let me explain. For walking, there are two basic requirements. Number 1, feet, and number 2, a surface to walk on. For a universe without friction, the surface will be 100% frictionless. That means you can keep moving your feet all you want, but without friction, you are not going anywhere. In reality, we don't have 100% frictionless surfaces. However, we have surfaces that have comparatively less friction. For example, a tiled floor with soap water all over it. It will be very hard to keep balance on such a surface. Same thing happens in F1 racing. The cars and tracks are specially designed to generate as much friction as possible. If you noticed, the tracks are curved around the corners. They use cars' angular momentum to further increase friction. At the same time, F1 cars are aerodynamic. It bars the air drag to slow the cars down. They aren't 100% aerodynamic, but they avoid most of the resistance. Friction isn't just about solids. It is about liquids and gases too. Friction concerning liquids and gases is also called as fluid friction. Let's say a human is swimming in the water. Is he able to swim without friction? Of course not. Friction is the most important part of it. Liquid's viscosity is something that creates this friction that helps a swimmer swim. When a swimmer uses his hands and legs to push water in order to move in a certain direction, it is the viscosity of water that creates enough friction for him to generate enough force. The more viscous the liquid, the more the friction. For example, water spilled will flow much quicker than honey. Since honey is more viscous, it creates more friction. Another example is oil and water flowing separately. Since their viscosity is different from each other, they don't mix. Let's see an example of friction due to gases as well. Have you ever seen a wind turbine? Its job is to generate electricity. The catch is, wind turbines uses wind friction to generate electricity. Its blades are made in a way that they move in a specific direction when force is applied. Moving wind strikes its blades and it creates enough friction for it to move and create electricity. If gas didn't have any friction, it would have simply moved around it without causing any hindrance at all. So, that is it for today. We will be back with another fascinating topic. Until then, keep looking up.